During the understanding process, what we're trying to do is model the system so that we can figure out where security vulnerabilities may be introduced. One easy way to think about this is in terms of a circle. So here we have a circle that represents our system as we would think of it ideally. But when we go and we build the system, it doesn't quite turn out this way. We end up having our features that are, somewhere inside that system, sometimes outside, and it doesn't follow the full boundary that we originally specified. And some of these will look like defects, right? These are bugs. These are parts of our system that didn't implement the specification that we'd originally designed. But others represent vulnerabilities. And these vulnerabilities represent the ways in which an attacker can gain access to our systems because they exceed the original design envelope that we envisioned when we were first laying out how our system would be built. Modern systems are really large and they're very complicated, but thinking about these vulnerabilities isn't just about their size and complexity. We also need to think about different types of vulnerabilities. The first is the physical security of the system. So if a malicious actor had access to a workstation where they could install a keylogger to learn the credentials of an authorized party, that is something we're going to want to think about. There's also system security. So how would our system react to an unauthorized party launching a denial of service attack against the system? How could they take advantage of this? There's also network security. So if an attacker was able to launch a man-in-the-middle attack, how would it influence this perfect conception of what we think the system should be? And finally, there's human security. So if an attacker was able to befriend or somehow otherwise take advantage of a person who was authorized to use your system, how could we defend against that? And when we're building this understanding, we want to think about security from all of these different dimensions. Distributed systems and cloud computing makes this process even more challenging because we depend on a variety of machines, operating systems, libraries, and platforms that we don't even have access to. So building an effective understanding for these is even more challenging than for a simple co-located system.